In this video, we're going to discuss the process of correlating rock layers. Now that we had an opportunity to learn about the different rules and processes involved with relative dating, we now need to talk about one last topic, which is correlation. So I want you to look at the image and notice on the image we have two different sets of rock layers on both sides of the picture. We have a set of rock layers on the left and a set of rock layers on the right. Now each of these layers looks similar based on their color coding. Now this is not a coincidence. The rock layer that's purple has a matching purple set on the other side of the river. The yellow rock layer has a matching set on the other side of the river, and same thing for the blue rock layer. Although these rocks are no longer connected, since they have the same sequencing and type of rocks, we can assume that these two rocks, or two sets of rocks, formed at the same time. This is the process of correlation. It's basically looking at rocks that are in different locations around the world and determining if those rocks are of same geologic age. We can determine that in both rock layers, the blue rocks are on the bottom, those are the oldest, the purple rocks are the youngest on the top. And we can infer through correlation that these rock layers are of similar geologic age and formed at the same time. So here's another look at the process of correlation. We have two locations, location A and location B. We know that they're two different locations because we can determine by looking at the environmental conditions near the top of the diagram that we have locations that have two different climates. Now, if we were to correlate their rock layers, we would find a lot of similarities. To start, on the bottom layer, the two white layers in location A and B, they match each other. Then next, they both have a match with their green layers. A little further up, we have a match with those yellow layers. They both have same red layers. And finally, near the top, they both have similar bright yellow layers. So you might be wondering, well, why does location A have an orange layer that location B does not? There's no match there. Well, that is exactly what an unconformity is. Location B must have, at one point, been subject to uplift, weathering, erosion, and deposition, and that orange layer was completely erased from the record. If we did not correlate location B with location A, we would have no idea that location B most likely once had an orange layer, but because of uplift, weathering, erosion, and deposition, location B does not have that orange layer, and now there's an unconformity at that very spot, marking that something was erased from the geologic record. Now, looking at this diagram, we can also look at the fossils that are within the rocks. Fossils can also be used to correlate rock layers. The rock layers that are green in both location A and location B have the same fossils. Same thing for layers, rock layers that are in red. This also tells us that these rocks in two different locations must have formed at the same time if they contain the same fossils. So fossils can also be used to prove that rocks are of same geologic age in different locations. So now the idea of correlation is going to bring up some important questions. We have two locations here again, A and B. And the question that could come up with, well, which rock layer is the oldest out of both locations? Now I know you guys already understand that oldest rock layers are found near the bottom. Location A and B both have a different bottom layer. So out of those two locations, which one of those has the older rock? Out of the two old rock layers, which is the oldest overall? In a class full of 8th grade students, who is the oldest 8th grader? Someone's going to have an early birthday, someone's going to be the oldest, someone's going to be the youngest. So in this case, out of locations A and B, we have two old layers on the bottom. Which one of those two old layers is the oldest overall? So to answer this question, I'm first going to look at the old rock layer in location B. If you look at that symbol, you'll notice that it's also found in location A. That layer is the oldest in location B, but it's not the oldest in location A. So it can't be the oldest overall. Here we have a winner. The bottom layer in rock in location A is the oldest. Now let's see if we can figure out which layer is going to be the youngest overall. So we know that the two young layers are near the top, but out of those two young layers, which is the youngest out of the both of them? Well, similar rule is going to apply. If we look at the young layer in location B, we'll also notice that it's in location A, but it's not the youngest layer in location A, so it can't be the youngest overall. This is going to be the youngest rock layer overall. So let's go through a procedure to kind of break this down a little bit further. So in this diagram, I have three different outcrops: outcrop 1, outcrop 2, and outcrop 3. You can think of these as three different locations. And I want to figure out of all three of these locations, which is the youngest rock layer overall. So the first step, I want you to locate all of the young layers in each column. And that should be really easy because it's going to be the top layer in each column. Those are all the young layers in each of the three locations. Our goal is to figure out which one of those three layers is the youngest out of all of them. Well, to do that, let's do step 2. Check to see if the young layer in each column appears in another column. If it does, it cannot be the youngest overall. So let's start with this brown siltstone. It's the youngest in outcrop 1, but it's not the youngest in outcrop 2. So it cannot be the youngest overall. I'm going to eliminate brown siltstone. Let's look at the green shale now. It's the youngest in outcrop 3, but it's not the youngest in outcrop 2. So it can't be the youngest overall. We're left with the red conglomerate. So the last step is, if the young layer in a column does not appear in any other column, we can say that it's the youngest overall. And if you look, red conglomerate does not appear anywhere else in the other outcrops, so it's going to be the overall youngest layer. Now let's switch it up and look at an example of the oldest overall. There's going to be a very similar procedure. So the first step, locate all the oldest layers in each column, and all the old layers should be found at the bottom of each column. Next, check to see if the old layer in each column appears in another column. If it does, then it's not the oldest overall. So let's start with the brown sandstone. It's the oldest in this layer, but it's not the oldest in outcrop 3, so it cannot be the oldest overall. The white limestone is the oldest in outcrop 2, but it's not the oldest in outcrop 1. Now don't worry about the lack of fossil there. We're still looking at the name of the layer, which is white limestone. And since it's not the oldest in outcrop 2, since it's not the oldest in outcrop 1, it's not the oldest overall. So we're left with the gray limestone. And we can prove this is because the gray limestone does not appear in any other column, which means it must be the oldest overall.